off then. So today we're talking about one of those new features from in 2016 regarding temporal tables. So I'm glad to see a number of you are interested in this topic. When I saw it get released, I liked what it looked like, and I know it's kind of a Rev 1 for Microsoft in this space. We'll talk about what's coming out in 2017 as well in this presentation, but we'll be focused today on what's in 2016 and what you can currently take advantage of. So let's get rolling here. You know who we are. You've probably seen this slide roll by. The only thing of real interest to you probably here is my email address. So it's there. It's your opportunity to take advantage of it. Today, we're going to be looking at what does a temporal table do for us and how would you use it? And that was the purpose of one of the survey questions we had, was how to use temporal tables. And then we're going to walk through the very tactical nature of creating that table, querying it, managing it, and just looking at some of the ways it interacts with data, and just working through that so you guys get an idea of what happens when you work with temporal tables and what it's good for and what it's not good for. So first of all, what is a temporal table? It's actually a history table managed by the engine. My guess is that a number of you are here to see if you don't have to manage a history table yourself. So as you look at what a history table does for you, we've been doing these for years. I'm in the BI space. So in business intelligence, and we built data warehouses, and we have this thing called slowly changing dimensions, and we go out and we actually have to build these things and manage change. Other people have this for auditing, or just to be able to see how things have changed historically. In a lot of cases, we take the time, we write triggers, we do a lot of works to handle changes and updates to our data. And then basically we push all that to a table that we can now have to figure out how to reference and bring together. So what's really cool about the temporal table managed by the engine is probably the best feature in my opinion that makes this great is the engine handles what is current. So when you go to query a table and you can turn on temporal table functionality without actually impacting your current environment, because now what it's going to do is actually write the changes to another table, but as far as the users or applications consuming the data will do, they're basically still going to be focused on current, so you're good to go. So you can expand capabilities both to your users and to your applications without actually impacting current environment. So some of the things that are handled there, it tracks all new and updated and deleted activities are all written to the history record. We'll walk through what some of that looks like. All of it's tagged over date and time. It is manageable. There's different ways to manage that. We'll talk about what that looks like. And then you can do things like query a point in time. What did this look like 3 months ago? In our case, we're going to be creating tables. We're going to look at what it looked like even 2 minutes ago. But all that's all capable, and you'll be able to do that. And you'll also be say, hey, between this date and this date, what was the shape of the data? So all those things allow you some historical analysis. The ability to actually plug that into your environment and use that information in a meaningful way is a good thing. Currently, however, one of the big things it doesn't do is actually does not pull through the current user or who made the change. My guess is there's a couple reasons for that. Is typically speaking, we're doing a lot of application-based work, and the system may not know, if you're not fully pushing through like their credentials through Kerberos or some other fashion like that, is going to say that this application made the change without identifying who the actual user was that made the change. So you're still managing the user on your end. The other thing it does is it automatically tracks all changes to the data. So you have no control over changing of dates or changing the period that a data is valid within the context of a system managed table. So we'll walk through some of those scenarios. Those are some of the common questions that come up around temporal tables. So these are, when we brought up at that survey, these are some of the most common uses for a temporal table. A data audit. If you need simple data auditing, this is the way to go. What changed and when? You can actually track all that, when it changed. If you're writing out the user who made a change to, like an updated by column or created by column, when that change, that change will be written to the temporal table as well as just not automated. So you have to actually track who did the change, which is a pretty common scenario. Point in time analysis. You're going to look and say, hey, what did my data look like at this point? And being able to just go and query for that date to see what was current as of that date is all part of that scenario. So that is some of the stuff that we'll look at, and you'll actually be able to do the data look and just see, hey, what does this look like right now? Anomaly detection. We had an issue. We don't know what happened. Data changes fast. If you're in a fast changing data environment, this is an awesome opportunity to collect everything and then be able to go back and say, okay, 4 days ago, we had a spike in inventory. We're not sure what happened. We show an inventory record spike, but we're not, so trying to track down issues, you can actually look back at the history and understand what happened. You can also look even further back across history and see, times when changes are high and when changes aren't high and those kind of things, and you'll be able to do that type of reference. Solely changing dimensions, basic type 2 support. I say basic because sometimes type 2 is very complex, but if you're managing your data flow through SSIS fairly straightforward, you may be able to use this to support your solely changing dimension work, especially if you're using views and other types of mechanisms to go after what the data looked like in history. This does give you some great opportunity to support that without actually having to write it and manage it yourself. And finally, repairing row-level data corruption. This is a nice way to say that someone did something wrong and we need to fix it, but we don't remember what it was before, but we need to get back to that state. Now you have a way to do that. You can actually look back to when the change was made, find the change that was made, and make that happen. Some of those interesting scenarios are those folks who have elevated permissions and delete a chunk of your data. This will give you an opportunity to go back and reinsert all that data. You could script out an insert statement and put it all back in and make that change after the fact without losing that data and having an easy way or without recovering from a backup or some of these other scenarios. You can just add it back in. When working with these tables, basically it's really not that. So we're going you can create or alter tables to support system versioning, which is what is called in T-SQL. So you'll notice in the with statement that we're talking about here, with system versioning equal to on, this will actually turn on the capability to support system versioning. Depending on how you have created a table, we'll talk about some of that. We'll determine how the history table works. But the basic columns you'll create, you use these valid from and valid to. You can name those columns anything you want to. I just use valid to, from and valid to. And basically, they need to be datetime 2 with generated always. So you have that context in there. You can see generated always as row start, generated always as row end. That way, that's the new syntax that's being supported in T-SQL for this. You'll add a period for the system time using the valid from and to date. And then, of course, turning system versioning on. Recommendation to you in this scenario is the field names, like I said, can be specific to you, but you can also hide them by using the hidden keyword. What this means is that if you add this into an existing environment, you can add them as hidden columns, and folks will not be able to use them. Or, well, they'll be able to use them, but they won't see them. So if they're not seeing them, it doesn't confuse folks who don't need to know that you have turned on temporal table support or system versioning. You're going to be able to hide that from the users. This is a really nice feature to keep things clean. And hidden doesn't just apply to this column. You can use the hidden keyword on multiple columns within your environment. History table can also be created, like we're talking about, with a specific table name. This becomes important when you're trying to manage it, and we'll show you some of the management things you have to worry about if you don't actually specifically call out the table name. It will create a table name for you. It's lovely. It includes a GUID. So if you're one of those folks who have actually done a lot of creating indexes and not bothering to name them, you know what that naming convention looks like. It's very similar for these history tables. So it's something that you'll want to look at and make a decision and say, hey, I want to name those so I can actually manage my system better. Querying for time. Just so we're clear, I'm going to get through the first round of slides here quick, and then we're going to jump over into demos, and we'll come back to a couple slides at the end. So bear with me as I get you the content here. But current, you don't do anything. This is why one of the things I really like about system versioning and the capability of turning this on in SQL Server is I can turn it on, zero impact to the people who are consuming the data. Using point in time, you use as of keywords. Range you can use between and or from to. At one point in time, there's a difference between the two. I believe that has been removed. I've not been able to identify what changed, but realistically, between and is pretty straightforward. We use that for other type of range definitions. But if you prefer from to, there might be a nuance difference, but from what I can tell, there isn't one, and most of the documentation doesn't reflect the change. anything completely within the range. This is something that you have to be aware of. Contained in means it actually, and we'll show those queries in this, but when you do a contained in query, the entirety of the record must be start and from within the range specified. So that would mean if you're looking for data that was in a certain state for a period of time, but you don't, if it existed beforehand or existed after, you don't care, only was contained in. I haven't found a lot of use cases for that, but it's there. It allows you to actually scope out things that were wholly contained within the data range. So, and then everything you actually use the keyword all and get every record back. So we can look at some of those select queries here in a moment. I want to bring up this. This is actually from Microsoft's documentation. Rather than trying to recreate this whole thing, I basically copied it here so you could see it. The reference is on the slide. Why this is interesting, as you can see here, it gives you the point in time using the data. So as of, you can see anything that was as of that date, slices right through it, so it has to exist in that period of time. Between and will pick up anything that has a start or end date that is within the range. And once again, contained in, like we were talking about before, is wholly contained within that space. So that purple record has to begin and end within the context of the range. And then current querying anything that actually exists now. And you'll see it talk about infinity, and basically they put a 12/31/9999 date on there. So, all right, we're gonna get out of this real quick. We'll come back to managing history. Let's jump right away into Management Studio. A couple things here. I'm running Management Studio. I'm running SQL Server 2016. I don't have 2017 involved. We'll talk about some of the changes in 2017, and they're really related to management, but none of the other functionality changes. So in this first query, let me go ahead and get this guy out of the way for a minute. In this first query, you can see I'm creating a table. Pretty typical things. I got an activity table. There's my valid from and valid to dates with the generated always on. I'm setting it up as hidden. That's my system time that I'm going to do with system versioning. I am doing this without naming my history table. So let's see what happens in the first round. So when we actually create this table, go back out to our Object Explorer, refresh, you now see that I have a system version table right here. And underneath it, we now have this temporal table. And you can see here that the temporal table is basically, hey, this is temporal table 4, giving some wonderful name, and which is really hard to remove later, because when you do this, when you delete a system version table, one of the things you have to do is actually get rid of the history table independently, because there are 2 different objects in SQL Server. But this is, you can see right away it's attached, and you see right here that we actually, a system version table now has a clock on it. So it tells you system version, as well as the, the keywords there. But if you're just looking at the highlighted list, you'll see it right away. So this is pretty straightforward. The history table contains in it the same columns: activity ID, name, description, valid to and from, as does the table here. That's our base table. One of the things you'll notice right away is that my primary key is not honored in the history table, which makes a lot of sense, because essentially I'm going to be duplicating that key over and over again. So I still have primary key support on the primary table, but on the history table, I do not have the same support. Although it is managed so that the activity ID, which is considered a primary key, will not exist, and it does not duplicate itself outside of the data ranges. So that's the basics there. So now let's create this with a history table. So I'm actually going to end up creating 3 different versions of my my history record here. So we'll spend most of our time as _2, because it has a name table and it's pretty straightforward to use. But in this case here, the only difference in my code is I added this piece in parentheses here, history table is equal to, and I gave it an actual name. So as you recall, the first time around, it just gave us that generic name like it does when we don't name other objects inside of SQL Server. In this case, we're going to execute this one, go back to Object Explorer, and what you're going to see right away is, assuming it refreshes on time, _2, I now have a history table called _2. So now I have actually defined my history table name, which means I can find it and I can do other work with that. Not a lot of work, but of course, but at least in this case, I can go delete it when it's time to delete it or manage it from that point forward. All right. So what's the third option? Well, we talk about creating a table, but we can actually create the history table ahead of time. So that's what we're going to do in the next statement. So in this case, well, one of the reasons I would do that, and this, especially if you're working in a data warehouse scenario, or you're going to have a lot of data that's going to be repeated, but you're going to have a lot of change, and you're going to try to manage the size of that table. What I'm going to do in my history table, in this case, is I create the history table as specified. You notice, once again, no primary key is defined. And I'm not calling out anything special. This is just a table. Until I reference it as a history table, nothing is as unique about this table from the other one. It's just a table within SQL Server. I create a cluster column store index so I can actually, if you're familiar with how column store works, if I'm expecting a lot of change, column store is actually going to help me reduce the size of the table and improve overall performance when creating the table. We do take a hit on write, but depending on your mileage vary, depending on how you have it implemented, will determine the impact on write as you move forward. While you can write to a cluster column store index now, it's still not as performant as writing to a normal table. So just be aware of that. Depending on your use case, will determine whether this is a good idea or not. So let's go ahead and create that table, and then we'll reference that in the next one. So we're going to go ahead and run these two. And then we'll just, just for reference sake, at the moment, you'll see that my history table lives as a primary table in the environment. Nothing special about it, it's just a table. But now that I have the history table created, I can actually create my new table and reference my history table. Because the name exists already, it's going to run that operation and attach it and make it a history table. So let's see here. And once again, refresh one more time just so you can see an object explorer. Now you can see that it's moved into a location as a managed table as for system versioning. This is really important if you have a table that exists and already tracking history. If you can make it fit into this context, you can actually get your history table to be converted to a system managed history table, allowing you to maintain history in a single table set moving forward. So you can actually reference an existing table that has data in it for history and move from there as well. You need to match the schema though, and so you may have some nuances where you may not have consistent valid from to, that kind of thing. You got to make sure the data work in that context. All right, so we're basically going to start inserting data into these and seeing what the data looks like when we start selecting out of the table. So I'm gonna go ahead and insert into all three of my tables. Basically 3 records that give me an activity ID, the activity name, and a description that goes with it. So this is going to go ahead and insert it, and you can see that I didn't have to actually. I don't actually call out the dates, nothing like that. That all gets managed for me, and then we just start the process. So if you recall on the tables, I've actually hidden the valid from and to. So let's do this differently. I'm gonna go ahead and. I know you're never supposed to type in a demo, but I do it anyway. So here we go. So if I execute this now, I'm going to get the current record, and I'm going to get no additional context. But if I actually call out the fields I'm looking for, you're going to see that I actually have valid to and from dates. So what this does is that means that if I would have had this been an updated table, I would have just had all the records that existed prior. I wouldn't have any changes required in there. And in this case, I get my valid to and from as dates, and I'm able to move forward in that scenario. Okay, now is where it gets to be fun. We're going to start doing some updates. So I've got these 3 updates. This was referenced to my birthday, which one of the times I presented this was on my birthday, so there you go. So I'm going to go ahead and do this. I'm calling out the activity ID and giving a new description. So we're going to go ahead and execute these updates. And we're going to wait a second here. And actually, we're going to go ahead in the middle here, just so you can see the data is being written. So now you can see my first one used to be my birthday. Now I've updated that to getting old. So, and then we're going to keep on making some more updates. In this case, we're going to update that same activity. So we're now going to have 2 records associated to that and run those as well. And this one's, we're going to look at system time too. And we're going to see all the records that were now been created. So as you can see here, if let's go ahead and order it by activity ID, and then that should be good enough just to see them all to group together. So if we order that, you're going to see that I now have 3 activity IDs, and because I'm using system time, so these are my primary keys. So it knows that I had 3 different variations, and then going from valid from, you can see the current record always has this 9999 date in it, and basically it's the end of, you know, the 10th, you know, 1000 millennium, whatever that is. But you know, so it gives you that the valid date and from range, and that everything else will be operated off of that information. So I didn't have to do anything to create this. I just continued to update, and the record is there. In the deletion scenario, which is what's next here, so I'm gonna get rid of the summon activity. We're actually going to see an end date with no, we're gonna have a record now that doesn't have basically a current record. So there's no current record now moving forward for what would have been going this past summit record here. It has a solid end date. It doesn't have essentially the infinity end date on it. So it will no longer show up in any current queries. So if we go ahead and prove that out, and you're going to see now that we only have the 2 records that are current. So once again, this doesn't change anything that the users would typically see. Once a record is deleted, it has actually deleted from the primary table, but it has a record in the history table that we can reference now using for system time. All right, so now we're going to go back. We're going to insert a few more of these. So in this case, we're actually inserting 2 new records, and we're going to do some of this work because we're going to do some more querying where we're doing ranges and those kind of scenarios. So let's get these inserted. And then now we're going to see a few more records added to our list. I believe we're going to be up to 7 rows total in our records. And you can see here that records 4 and 5 are new records. So they have a later start date and time than anything else, and but they are also part of the current record. So we're able to work in that context. So let's see here. And I think this is pretty much the same for current. You're going to actually see valid from and to in all these scenarios. I actually don't have it hidden, so we got to put twice. But this lets you see that we have all those records available, and we can see the valid dates are all, the valid to dates are all the same. So, all right. So that's the basics of creating and inserting what happens in the basic querying patterns. Now let's start looking at what actually is being dug into here. So I'll explain, so all the stuff of the data that we've just been creating today, so I create a couple variables to give us some different date ranges that we can work with. So the first thing we're going to look at today is as of, from a querying standpoint. And as of is basically going to say, hey, I need to know what the data look like as of this date. So we're going to use the valid from, the first valid from we have. And so what did it look like when it was as of that time? And we're going to execute this. So as of 7/25 at 15/22, these are the current records we had. You'll also notice that in this scenario that the valid to date, only one of those records we have is still current. The other 2 records have either been updated or deleted. We don't have any definition around what, if there is a valid to date that matters, because we're looking as of. So when we started this process, the first thing I entered into the environment was we inserted these 3 records here, and now I have these 3, you know, that's all I get is these 3 records. That's all it was valid at that time. So it doesn't really matter what the valid, you know, as long as it drops within the range between valid from and valid to, we're able to get that. And you see it's inclusive on each end. So the difference between that and between end is between end, we're going to look at, basically, I'm going to subtract 2 minutes from the valid from date. From the largest valid from date to figure out what we have, and we're going to run this, assuming that the timing is right. I've talked long enough. There we go. So in this case, you know, we had 7 records total, and the only ones that actually fall between the beginning of the year and at 324 on this server, then you're like, all right, so where are we at? And this is going to say, okay, so I can see I have the 3 changes I made here. I have two current records, that's it. And obviously in this case, it's either current or it's been deleted, we're not sure, or it's still been deleted or has an update that falls outside the range. And that's why I don't see another record for 3. But you will see that both of my updates did show up, because both of those updates for that first record, we're talking about older, getting older, and getting old. So I have my current record, but I also have the 2 updates that occurred because both those updates had either a valid to or valid from date that fell within the range that we're talking about. And the important part here is it falls in the range we're talking about. So we're doing between and, or like in the next example, from to. Both of those, you're working within a range. So in this case here, we're basically, looking to later date information, so more current. So if I execute this one, we're going to see that we really only have current records because I worked from, a valid from date that was older. So basically, all I get is current records in this scenario. But it's the same kind of thing. Both of them, the valid from or valid, valid from and valid to, beginning and end, somewhere in that range, has to fit within the range as specified in between and from to in order for it to be included. And if any part of it's included, or any updates are included, or anything like that are included, it will include that record, including all the history records that are associated to that. So this is one of the things to be aware of when you're using this, that if you're trying, once you start working these range dates and working with system time, it is very likely to get duplicate records because they were not technically duplicate. They're actually valid from one point in time to another. Then we get back into, once again, just looking at what everything is there. So here's all that data once again. So remember that, we still have 7 records, and this only one of them actually is deleted because it actually has an end date. The other 2 are updates. Contained in. So in the contained in environment, basically, we are going to say that everything about this change has to occur between the date specified. And this is always fun when I do this. It depends on the timing I've talked. Determine if it actually fits in the contained in range. We do have 2. So in this case, the 2 updates that I created are the only things that actually are wholly contained within the date range specified. So between 1522 and 1524, I'm tracking that change, and all I want is stuff that can happen between those 2 time periods, and that's what we have. So now as you look at that, what that means is that, I don't have any context of anything else in history. That all I know is that these records are the only records that wholly existed within the time frame called, and that they don't go beyond those boundaries. So, well, it's very important to understand the difference between these 2, depending on what you're trying to accomplish and what you're trying to look at, will determine which one of these makes the most sense, whether it's as of, between and, from to, or contained in. All these query types support the ability to query across that. As you saw, all is also included and basically supports everything you see in history, which is really more for auditing or for reviewing things in whole. But now you can actually see all the changes that occurred. So if you're troubleshooting a change, you can look at an as of date to say, hey, I need to know what the data looked like as of this date, so I can actually, deal with that. I want to see everything that happened, and you're looking at all the activity happened, and then you're looking at a range either between and or from to. I'm getting a range of all that information. Or I'm looking for where all the changes occurred within a certain time period. And that may be helpful for troubleshooting if you're looking for data that was modified in a specific time range, and those modifications are incorrect. You can go look at that data and then start to work forward from there to do changes you might need to do, and you have a full history to work from in that scenario. All right, so we already talked about all. One of the things that came up in one of the previous things we talked about is what happens during a transaction, which is really a very common question if you're an application developer. So how many changes are actually recorded to the history table? Well, the answer is, if you roll back, no changes recorded, because that would make sense because you never actually instituted change, so I won't demonstrate that. But in this case, we're looking at an insert and an update within the same transaction. And what happens here is that if you do a dirty read, you can actually read the insert before the update occurs, even though it's on technically the same record. So I'm going to create a new record with a value of 900. it just tests this. So we're going to do begin transaction and insert. And so now we have we have an uncommitted transaction on that. So if you're running a no lock scenario and you happen to be running for system time all, you will get that information. So now I'm showing this as the insert. So with a no lock in place, I'm getting an insert on that record. Next thing that would happen in that scenario is like I'm gonna do an update. So you see the insert does show up in the history table. This is really important. It does show up in the history table while it's occurring. So even though the rollback, if we roll that back, that record will be removed from the history table entirely. So if we execute the update next, and let's see if we can do this. Sometimes I get locks in interesting ways. And I don't know if this is going to show or not. We're going to go with not, so we're going to break that. So at this point, we've actually have an update sitting on the log as well. Now we commit the transaction. And you're going to see the only record that shows up is the update. So if you need to track individual items within the transaction, you're going to have to commit them individually, which I know is unrealistic, depending on how you could be unrealistic, depending on how you actually build your application or do your inserts. But be aware that that is how that works. So if you're trying to minimize the amount of history you're actually tracking, so like it is common to do an insert update, other modifications before the record's fully committed, then you will need to be aware that that's exactly what's going on within the context of the environment, so that you can actually understand what the changes are and manage those changes appropriately. So that gives you kind of a quick rundown of the queries that are involved, and what the capabilities are within SQL 2016 to support that from both a query and data, a content creation standpoint. Let's go back to the deck. Managing history. So one of the bigger questions that always comes up around this is what happens when I have a monstrous history table? What should I do with it? So there's some recommendations that come from Microsoft and some of the stuff we want to talk about. So one of the things I want to, stretching your database. So if it becomes a data center storage issue, you can actually stretch your database out to Azure SQL Database, and you can move all or part of your history table. Remember, keep in mind that if you move your history table to Azure SQL Database, it will incur a read penalty because you're going to have to connect the data over, with analysis services. If you are already a hybrid shop, this may be an ideal scenario to extend something on-premise or even from a VM in Azure to an Azure SQL Database for stretch. What it will do for you is provide the capability to push that data, hopefully to lower cost storage at the end, and have it still be available without actually maintaining those assets. Ideally, this is one of those scenarios where you may be paying a premium for your storage on premises, and you want to move that to, move that cost off for history tables into Azure SQL Database. Ideal opportunity. Be aware, stretch databases currently only support stretching to Azure SQL Database. So there's not another option for that. You just have to push it to Azure SQL Database if that's what you want to do. Table partitioning, this is very similar to some of the common partitioning techniques we've used before with rotating partitions, and there's a good techniques around that. So if you, say you only manage a year of history in these tables, you can use a rotating 12-month or 13-month partition, roll off the end partition, and move forward with that. Now, what you will find, and this is where the next one is one of the most common use cases that I see today, is that you will write every change to the table as you saw, unless you're enclosing, transactions. So if you're doing a load of data or something like that, and it writes a bunch of changes, and sometimes writes a change that's not a change, so it kind of says, hey, I'm going to update that record and make no changes to it, and it generates an update. If that occurs a lot, or you have some of those scenarios where you're constantly touching the data, now you have a huge history table, which is really not that helpful because it doesn't reflect some of the changes. You can actually go through and custom clean it up. What I would definitely recommend is handle with care, because first thing you're gonna do is turn off system versioning. So when system versioning is off, all the temporal features are off, you can actually go out and modify that history table and get the data to reflect the way you want it to. But keep in mind, you're now outside the automated process. Then you'll turn system versioning back on, and it'll continue to maintain the data moving forward. And it will still work with the historical data that you've modified. You can't modify it while system versioning is on, because the SQL Server manages that table and will not allow you to actually handle that. Temporal history retention is coming. So SQL Server 2017, which just RC'd, I think it's RTM yet, but RC'd, and SQL Azure database, which I don't have a demo of right now, do support history retention periods. So now you can say how long I want to have the history retained, and it will manage that retention. I don't have an example of how this works, but you do have context for days, weeks, months, or years. I can definitely see this be a common scenario where really you need rollback capability or replay capability, say 3 months back, for modifying things in the history, or you audit differently. Whatever those scenarios are, you can actually start adding that as another attribute onto your history table, so it'll be self-managed and do what you want to from that perspective. Keep in mind, once the history goes beyond the retention period, it's no longer available to you, and you don't have that history. So like with anything where you're removing data, you need to make sure it meets the criteria that you have, so that you can then roll that off and do other things with it. And that is the basics around doing temporal tables. So now we'll open that up for questions. I don't know if we have questions yet, Erica, or not. So
yeah, we do have a lot of questions. However, some of them are specific to certain points of the presentation.
Okay.
Let me see here. Okay, are there new SSIS tasks to work with temporal tables?
There are not, and that's primarily because the temporal table, even SSIS, has no, there's nothing special about it. It's all SQL based. So you're not going to write to the temporal table. If you need to manage that, you saw it was custom work, you could actually do some custom scripts and SQL there to actually turn off system versioning, do some management. But realistically, once you write a change to that table, whether using SSIS or some other tool or reading from it, it's done automatically by the system. So there's nothing for SSIS to do in that scenario.
Okay, here's another one. How can you add temporal tables to the existing table? Does it require scripting?
You have to run an alter statement and add the columns we're talking about. So let me flip back here real quick. So when you can actually alter the table, and you're going to add the with statement and the column, the fields you see here on this page. So that will actually take care of, it's basically altering the table to support this. It's similar to the create statement. You're just using alter, or you can use, if you're in SQL 2016, you use create or alter on the table as
well. Okay, here's another one. Do you have an example of cleaning up the history table, i.e. removing data that's over a year old?
I don't, but because I'm one of those people who like to live demo, let's look at this table here real quick. I don't have a year, so let's look at what my data is. So you would actually have to do, we're going to try this live, everyone, so bear with me. System, let's go look at my code here. I'll let us say just type it from scratch, but I don't want to screw it up. There we go. So I'm going to grab this real quick. So we were doing an alter table with system versioning. We're going to turn this off. Where did I mess it up at? Oh, parentheses in the wrong spot. So we executed everything. My bad. Let's see if I dropped the table already. I probably did. All right, so basically what you would do is you would actually alter the table, and I'm sorry, I'm messing up the syntax here because I'm doing it off the cuff, and set system versioning to off for the table. Once it's set to off, the history table no longer is a history table. It's just a regular table. So like you can look here, here's an example. So in this case here, we can grab, we'll grab this table, so this. I think it's history. Yeah, I don't have data in there. But that table, you'd actually be able to delete with the date range using the valid from to date. So sorry, I screwed up my data by hitting the button too quick. But basically, you can do, once you do that, then you can go back and set system versioning back on your primary table, and it will go back to working as expected. So that's all done through alter table. And you know, if you have a standard practice, you could actually set it up to run a script on agent or whatever to do that same work. So my bad on the context there.
Okay, here's another question for you. What limitations are there with SCD2, especially with surrogate keys?
So there are no surrogate keys. So if you're using a surrogate key managed SCD2, you're not going to be able to take advantage of this in a way that makes sense, because every new record will get a new ID. And so if you're going to do that, you probably would want to start with only new items, because really it does not generate a key. So what happens is you'll be managing your fact table using the natural key. So it would automatically have, support this. One of the reasons we always had surrogate keys is because this type of functionality didn't exist. So now it does. Problem is the historical way of doing it really is not compatible due to how surrogate keys are managed. Because in this case, I could actually get out surrogate key management, which is one of the reasons I like it. But as you get to complex, slowly changing scenarios, like I only want to do slowly changing on 3 columns, not the entire thing, that can't be done here, because any change to any record is always applied here.
Okay. Let's see. How can you join 2 temporal tables to find a point-in-time view of multiple related temporal tables?
Well, you would just basically do like any other join. Depends on what's related. So if you're doing a lookup field that actually isn't temporal, then it's really easy. You're just going to join the table and the context. But if you're doing tracking 2 tables or both tracking history and you want to join both of them together, it depends on how you join them, right? So if they actually have, like, one is, let's take a common scenario like with a ticket. On each, like a sales ticket might have the ticket itself and the details, and for whatever reason changes could happen in that. So an order and order details, and you're tracking the change. If you're tracking the change on both of them, and as of date in each of those will actually get you what the ticket looked like or the order looked like and its details at that point in time, just by joining through, like from the order ID to order details, or joining it back to the order using the order ID. It's pretty straightforward. So it's just really a matter of how you filter each of those contexts and then join them together. The as of date will work in both, depending on how your data is entered, of course.
Okay. Stephen asks, how would Power BI be able to take advantage of these tables? Does it have the ability to send the correct SQL statement to present the correct visuals?
Okay, so let me answer that question. Depends on how you do it, because I'm a good consultant. If you actually load data and you want to bring the historical data forward, then I would recommend that you load a current version of the data and a historical version of the data into your Power BI model. So if you're actually loading the data into your model, that's the approach I would take. If you're using direct query, then it's just like any other SQL statement. You can apply this at however you want to do it. So if you're sending, basically if you're doing a data call and it's using the fields, it will do it. The biggest problem you're going to have is that because of how Power BI works, you don't have a lot of control over this actual SQL statement at times, depending on what you're doing. So once you get the data inside of Power BI, for instance, it's really about how you can work with DAX and other mechanisms to actually query that data as opposed to T-SQL. So you can write a SQL statement to bring all the history in and work from that perspective. It really depends on what your use case is and what you're trying to accomplish.
Okay. Kathy asks, are history tables handled as heaps?
Yes, because there is no clustered index on those that I'm aware of. I didn't look. I think you can add a clustered index, but it just cannot be unique. But you know, like we put a clustered column store index on one of the tables. So you can put a clustered index on, but there's no primary key, and there can't really be a unique key in there because that would actually break the system table.
Okay.
It is you can independently index the history table for performance. That is fully you can do all that. So.
Okay. Next question: can we choose to keep history only on selective columns and not on all? And
nope.
Not all
currently
columns.
Currently, that functionality is not supported, which makes it that's why the use case for slowly changing is so weak. Because if you have a particularly wide dimension table and you only want to track change on 3 or 4 columns out of like 20, that's not supported at the moment. It's any change made to the record will be written.
All right. Can you have a scenario where the temporal tables can have blocking locks, or any situation where a temporal table can have a negative impact on the live product table?
I am not aware of anything, but it probably really depends on your environment and how you're actually loading, because it is a part of the transaction, as you saw. It seems to be pretty lightweight from that perspective, but I haven't tested at that level of scale to see if there's other issues that pop up if you're trying, like huge amount of writes. It's fully supported in column store, and I believe it's supported in memory optimized as well, which would imply that you should be able to get an even higher level performance out of it if you run that method. But I'm not sure on the in-memory. You'd have to check that one. I'm not sure.
Okay. Next question: how would you implement a slowly changing dimension?
Basically, I create the base dimension, and if I knew when I loaded, I wanted to track every column on that, I would just let it do its thing. I would not use a surrogate key. So it would use a natural key, and the natural key would be implemented in the fact table. So there would be no surrogate key lookup. And then whatever for current, so like if you're using reporting against it, I could report current against it, no problem. If I need to report history, instead of using my own custom columns built around history, I can actually just go and use the system date functionality, or system time functionality, I'm sorry, then go from there. It actually is pretty clean as long as every change in the table needs to be typed to. So it'd be fully functional within both outward tools like reporting services, analysis services. All of them would be able to take advantage of that because you just change the query.
Okay. What are the differences between CDC and temporal tables?
CDC is a log. It actually captures changes for replication purposes, so you actually move across systems. So if I'm using a lot of CDC, typically I'm trying to put that data somewhere else, or it's a fairly heavy lift from that perspective. Whereas this is just a SQL manage. It's not going to have the complexity, nor is it going to have the capability of CDC overall. If you only are trying to track changes, and I see this as a great auditing scenario where I want to remove a bunch of triggers, that type of scenario, or CDC is used for audit. This gives you an option to handle all that. If you are using CDC for other controls, this is just writing to history table. That's all it's doing.
Okay. What's the difference between temporal tables and Azure data lakes?
Well, this is SQL Server, and Azure Data Lakes aren't. The history table is stored as a relational table. When you're thinking of a data lake, that is going to be Hadoop based. So in that case, you're pushing files out to that environment. It's not a relational engine. So that's the biggest difference. They're completely different technologies.
Got it. Do you have an example of joining two tables together using temporal tables for a point in time?
I do not have an example, but I will make a note to create one.
Okay. If you create a view using the parent table, would it automatically include the temporal table?
If you call it out, yes. If you don't, no. So one of the things I didn't show was in the execution plan. If you don't specify a system time filter, then the history table is never queried. But if you specify a system time filter, then it is queried. So if you use a system time filter in your view, then it's using a history table. Otherwise, it will never reference that table.
Okay. Does a truncate get captured as deletes in the history table? The person that asked this question assumes yes, but wanted to confirm.
You know, I didn't truncate. I'll have to get back to you on that one.
Okay. If you add a new field to the current table, does the new field automatically add to the history table?
Ooh, I don't believe so. I think you have to create a new column. All right, sounds like I got a few things I got to track down for everyone.
Yeah, and I'll be sending you these questions later so you can.
Oh yeah, it'll be fun.
Can we control, or let's see. What kind of performance hit do you incur with the system versioning? With the system versioning enabled on a table with heavy updates?
Well, you're going to incur some penalty because you're writing that, and I believe it's all part of the same transaction. So as that's occurring, you're managing multiple transactions during the updates. However, I mean, if you're currently running triggers, the impact is actually less than triggers from everything we've seen so far.
Okay. Looking for more questions here.
While she's looking, I just want to let everybody know, now that I have a list of other questions, I'll work to get this out on my blog with a full list of answers to the questions, as well as all the scripts. The actual presentation I'll hand over to Erica, and she'll make that available with everything else. So
yeah, I plan on putting, as always, I'll have the recording up on the website later today, but I know I've had a couple people on here asking for the slide deck as well for reference. Yep. Here, let's do one more question. Can you put a history table on a different file group or a different drive?
Yes, to have both of those. Because it's actually created as a separate table at the end of the day. What I'd recommend in that scenario is that if you're doing that, I would create your own history table like we did in demo 3 and specify the history table where you want it, all that type of stuff, then turn it into the history table to support your environment. That way you can get all those pieces in place and then apply system versioning when the system controls the table after the fact.
Okay. Can you, I think this is from earlier in the presentation, can you update valid from valid to date in the base table using the update statement?
No, that you cannot do. That request was made earlier to me as well, actually just today by someone on our team, and that is not possible. You cannot, those dates are not modifiable. They're system managed. Unless you turn system versioning off, in which case it begs the question, what are you trying to use it for, and if you need to manage it on your own.
Okay, I think we have time for one more question here. What data types can be included in temporal types? Can these data types, text, untext, binary, image, be included?
I'm not aware of any limitation. Excuse me, but that's primarily because I didn't try those, and I don't recall reading anything about that. That is an easy thing to test because it'll wrap our day up with either an error or something good. Let's see here. Let's grab this guy. Oh, I already have an object. Figures I already have it there. Let's go up here and I need to drop this one. Okay. See, at least this part's easy. I'll just have to come in here and fix this later. I broke my demos, yay. Yeah, it doesn't, I didn't see any data type issues, so it appears that it supports any of the data types. I mean, I'm just using varchar max at the moment. We could look at binary and some of the other ones, but yeah, I think everything's fully supported from that perspective.
All right, perfect. There are a lot more questions that you weren't able to address, but again, I'll send those to you later today if you want to, answer those. But in the meantime, it's a little bit past noon, so I'm going to go ahead and wrap up the webinar. Thank you, everyone, for joining our webinar today. As I mentioned earlier, we will be sending all registrants a follow-up email that includes a link to the full recording of today's webinar. You can also find the recording on our website at pragmaticworks.com. So thanks again for your time, and we look forward to seeing you all next Tuesday for another free training session. Thanks, Steve.
Thanks, everyone. Yep,
Take care.
Thank you.